Hey everybody, Chapter 7 is all about different techniques of integration that we're going to look at. So the first type is called integration by parts, and this is going to most resemble essentially reversing our product rule that we learned back in Chapter 3. Okay, so we're going to identify that this is the method that we'll be using based on if we're looking at a product. We saw in Chapter 5, 5.6 specifically, that there were some problems that we could reverse or anti-derive by using substitution method, and that would reverse the chain rule essentially. Here, if it's not something that can be done by substitution, the next thing to take a look at would be integration by parts, and it must be a product rule. So similar to product rule, right, where we identified two different functions, we're going to be doing the same thing here. We need to be able to identify a u in the integral and a v prime in the integral. And if we were to take a look at working backwards a little bit for a second, the original product rule, we knew it as uv prime would be u v prime plus u prime v, right? Where only one of the functions was being derived at any given moment. So same idea here, only one of the function is being anti-derived at any given moment. So uv can be rewritten as the integral, if we were to integrate both sides or anti-derive both sides, the integral of u v prime plus u prime v. And therefore, if we're given one of the integrals and we can identify a u and a v prime, and that might change, doesn't really matter what the order is, then that's equivalent to uv minus the antiderivative of u prime v. Okay? So our first job is to approach an integral, see that it's a product, and identify a u and a v prime. Okay, so our first example is the integral of x times cosine of x dx. Okay, your job is to make the problem as simple as possible, right? So I want to pick my u here to be x, because if I picked my u to be cosine, although cosine is easy to derive, I wouldn't want my v prime to be x, because then I'm anti-deriving x and bringing it to a higher exponent, which I don't actually have in my example. So u is going to be x, v prime is then going to be cosine x. And anytime I'm learning a new rule, out of good practice, I always rewrite the rule on the page somewhere. So I know that I have an integral of uv prime here, dx, I'm a little shorthand right now, equals uv minus the integral of u prime v dx. So this is what I'm looking for, right? So I need all of my parts. I already have a u and a v prime, so I need a u prime, which is 1, and I need a v, which if I anti-derive cosine, I get sine x. So now it's just a matter of putting things back together, right? I need, my answer is going to be, so if I'm anti-deriving x cosine x dx, or in other words, if I have in my integral u v prime, then it is going to be equal to u times v, so x times sine x, taking those pieces, minus the integral of u prime v, 1 times sine x dx. Now typically, this next line of work, I'm able to now anti-derive using a singular rule. I don't typically have to redo integration by parts, but sometimes you can. So now integral of x cosine x dx is equal to x sine x, and the antiderivative of sine x is negative cosine x, so I have two minuses, so I get a plus cosine x plus my c. Okay. Now the nice thing here, especially when I'm doing a new rule for the first time, I can always check by deriving, right? Everything in the integral unit you can derive and arrive back at what you started with, right? Go full circle. So if I did derive it to check my work, x sine x is a product rule. So x goes to 1, sine x stays, plus x stays, sine x goes to cosine x, minus sine x, c goes away. So cancel, cancel. I'm left with the x cosine x, which of course is what I started with in my integral. So there's your first example of integration by parts. This example is one where we could have a good versus a bad choice. So in this example, depending on whether I choose my x or my e to the x to be my u and my v prime, I could end up making this problem more complicated. So similar to before, I tend, if I have an x and I know I need to derive that, unless I have other terms with higher exponents in it, I want my u to be my x, because when I derive that, it goes to a 1. If I picked it the other way around and I had to anti-derive an x, that's going to bring me back to a 1/2 x squared term, which would complicate a problem that doesn't need to be complicated. Okay, so again, writing out my rule that I'm using, I have a uv prime dx equaling a uv minus integral of u prime v dx. So u is x, v prime is e to the x. Then the other pieces I need, u prime is 1, and v is e to the x. Pull it all together. So the antiderivative of x, e to the x dx, is equal to x, e to the x, minus the integral of 1 e to the x dx. Right, so now I have that one integral left to do. So my answer is x e to the x, and the integral of e to the x is e to the x plus c. And again, if I wanted to use the product rule and derive this, I could derive this and get back to the original problem. So example 3 is going to allow us to do integrating by parts more than once. Okay, so the initial approach is nothing different, right? I have a u, I have a v prime, antiderivative of u v prime dx equals uv minus integral u prime v dx. Okay, great. So u is x squared, v prime is cosine x, u prime is then 2x, and v is then sine x. All right, pull back together what we know. So uv would give me x squared sine x minus integral u prime v 2x sine x dx. Okay, so I can't derive or anti-derive that integral as it is. I have to use this integration by parts again. So again, my u is 2x, my v prime is sine x, so my u prime is 2, and my v is negative cosine x. Careful with your signs here. So x squared sine x minus the quantity uv, so 2x negative cosine x, or minus 2x cosine x, minus the integral of u prime v, so 2 negative cos x, or negative 2 cos x dx. Okay, so now I've rewritten it enough, so the integral that I have left is something that I can evaluate. So I have an x squared sine x plus 2x cosine x. Now the antiderivative, I'm going to take this negative with this negative and turn that into a positive in my mind at the moment. So now I'm anti-deriving a positive 2 cosine x, which goes to a positive 2 sine x. But I still have the original subtraction in the front of the parentheses. So it is minus 2 sine x plus c. Okay, so I really had a triple negative going on, so that kept it negative. Okay, a few more examples in this section. So now we're looking at one that is a definite integral. Like, what do we do with those limits of integration? They still have to go to the u and the v portion of the integration by parts rule, as well as the u prime v portion of it. Okay. So this example is in ln x. They're telling us to use 1 as our v prime, right? It doesn't look like it would be an integration by parts because it's a single term in there. But remember, we didn't have some rule that told us that this equation derives to ln, right? We knew that ln derived to 1 over x, but nothing derived to ln. So that's why we don't have a straightforward answer right here, even though it appears to be a straightforward integral. Okay. So u is then ln x, and v prime is 1. Therefore, u prime is 1 over x, and v would return to an x. So this is equal to x ln x from 1 to 3, that's this portion of the rule, minus the integral from 1 to 3 of u prime, which is 1 over x, times v, which is x, dx. So I can evaluate the limits of integration in the front. So I have 3 ln 3 minus 1 ln 1, which is just a 0, minus, inside of the integral, I have 1 over x times x. I have a 1. So that returns to, or that anti-derives to an x from 1 to 3. So I have 3 ln 3 minus 2. Okay, this one gave us the heads up, right? It says going in a circle. So we know that if we derive or anti-derive e to the x, it stays the same. And we know that if we take cosine x, it's going to go back and forth between cos and sine, obviously changing between positive and negative. So it's no surprise that if I do integration by parts, we're going to kind of fall into a trap. So we have to be ready for that. We don't want to keep doing work without coming up with some type of solution. Okay, so let's start this off. And again, we've typically taken the first term and called that the u. And in this case, for no real rhyme or reason, because you could go the other direction, but I'm going to call my u cosine x. And again, I could approach this the other way, but just be consistent with it so that you don't cancel things out and really fall into a different trap. So anyways, u is cosine x, v prime is e to the x. So u prime is then negative sine x, and v is e to the x. Okay, so the integral of e to the x cosine x dx is equal to e to the x cosine x minus the integral of negative sine x e to the x, or negative e to the x sine x dx. Okay, I'm just going to rewrite this with pulling that negative out. So the integral of e to the x cosine x dx equals e to the x cosine x plus integral e to the x sine x dx. So we're at a place where we really just have to repeat the process with integration by parts of e to the x times the sine x. So now, being consistent with how I chose my u and v prime before, u is sine x, v prime is e to the x, so u prime is cosine x, and v is e to the x. So integral of e to the x cosine x dx equals e to the x cosine x plus e to the x sine x minus integral e to the x cosine x dx. Okay, so there's that complete circle, and what I mean by that, right here is what we started with. So if I begin again, of course, I'm just going to go through that exact same pattern. But what I can acknowledge, and here's the reason that I kept writing the original problem on the left-hand side, right? Because they are the same, they're like terms. I can add that integral. And if I add that integral to the left-hand side, I have two integrals, e to the x cosine x dx equals e to the x. I'm going to factor that out. Cosine x plus sine x. Right. And then I can go ahead and divide by that too, and I'm done. So I was always solving for integral of e to the x cosine x dx. So it's exactly e to the x cosine x plus sine x plus c. Okay, this is the last example in this section. So this is using the reduction formula. And otherwise you could see that this would be something that of course is repetitive, and it could take a little bit longer if you didn't follow along with this. We saw how it worked in one of the previous examples when we started with the x squared and it went down to a 2x, and then you continue from there. But more specifically, if you have x to the n times e to the x, because of the nature of the repetitiveness of e to the x and the way that x to the n with power rule works out, the integral of x to the n e to the x dx will always antiderive to x to the n e to the x minus n times the integral of x to the n minus 1 e to the x dx. Right, and we're going to evaluate this specifically using integral of x cubed e to the x dx. So whenever you are looking at a problem like this and you're using the reduction formula, you're identifying in general that your u is x to the n and your v prime is e to the x. Therefore, u prime would always be nx to the n minus 1, and v would be e to the x. And you could go about this the long way to prove it. All right, so for this example, integral of x cubed e to the x dx, following along with the reduction formula, it would initially become, you have to go through each step at a time, but it would initially become x cubed e to the x minus 3 integral x squared e to the x dx. Right, and then we can use the reduction formula again. So now we would have x cubed e to the x minus 3 times quantity of x squared e to the x minus 2 integral x e to the x dx. Then we would have x cubed e to the x minus 3x squared e to the x plus 6 times quantity of x e to the x minus integral of e to the x dx. And now we no longer have this power using the reduction formula, so we can just antiderive that e to the x at the end. We would have x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus a c. Right. And most simplified version of the answer, I can factor my e to the x out, leaving you with e to the x times x cubed minus 3x squared plus 6x minus 6 plus c. Right, so focusing there where your current exponent is your n term, and then inside of your integral you're always reducing the n powered by 1 until there's no longer x to the n remaining in the integral, and there's just e to the x. Okay. So summary on this page, it's in the textbook as well, but the main thing, right, the common theme was reversing our product rule, identifying a u and a v prime in the original integral, and finding the other pieces, pulling it together, so you then had a uv minus integral u prime v, and you repeat that process until it's something that you can antiderive all the way back to its original parts.